Hi guys, welcome to the most comprehensive preparation app for all the competitive exams, that is BYJU'S exam prep. So today we are going to discuss the top 15 questions, 15 most important questions of theory of computation. A warm welcome you all to my session. So please quickly join and also mark your presence. Yes, good evening Chandan Kumar and Sachin, good evening. So please join quickly and also mark your presence. Please let me know whether my audio, video, everything is fine before we begin the session. So please all of you share the class information with your friends and do subscribe the channel. Yes, and this session is going to be very interesting because this most tricky subject of computer science for the GATE examination we are discussing today. So I hope every one of you are involving in this, and also you will answer the questions. So let us discuss all the questions. Am I audible? And please share the class information, do like the session and also subscribe the channel. Am I audible? Yes, Chandan Kumar. So requesting everybody to please share the class information with your friends so that they also can join. So let us have a discussion of all the most important 15 questions which are likely to come in the GATE examination, GATE 2022. Yes, Sachin Gangwar. So very good evening. Okay, thank you very much for your response. I hope my audio, video, everything is clear. Yes, now let us start the session. So meanwhile, just before I begin the session, please share the class information with your friends and subscribe the channel and do like the session. Okay, so now I am just moving forward. Very nice to see all of you once again, and you have been enjoying this type of sessions, I think, since last month, and also we will be conducting some more sessions. Yes, please quickly join. And so in theory of computation, just before discussing, let me introduce myself. I think most of you might be knowing about me because I have been taking different sessions in the app and also in paid classes. And myself, Muralikrishna, I am having 21 plus years of teaching experience, and these are some of my credentials. You can just have a look at this. And I mentored more than 50,000 students and certified as international engineering educator, and I'm topper in NPTEL course of theory of computation conducted by IIT Kharagpur. So that's what is the subject I'm teaching you right now. And my area of expertise is theory of computation, operating system, computer organization, computer networks, digital logic, and information and communication technology, that is for engineering services. Yes. So are you sharing the class information with your friends? I hope every one of you are able to listen to my voice. Is it clear? Okay. So meanwhile, whatever the doubts you are, yes. Chandan Kumar Jaiswal, good evening. Fine. Okay. So let me start the session. So before that, actually GATE 2022 Maths and Apti session is there, series. You can score 28 out of 28 after attending these sessions. It will be starting from 22nd June, already started. So by Rakesh sir and Ankit sir, you can attend these classes regularly. For mathematics and aptitude, you know, the aptitude is for 15 marks and mathematics remaining marks, total 28 out of 28 you can score if you attend this special classes, that is by the Rakesh sir and Ankit sir. I hope every one of you will take this and get an advantage of these classes. And let's move. And these are the engineering services prelims. You can share with your friends who are appearing for engineering services. So then some non-technical session will be there daily at 10 p.m. So these are the dates. You can just have a look at this. Yes. Okay. Yeah, Chandan Kumar, thank you very much. Hi Varsha Rani, good evening. Good evening everybody. And as you all know, this subject is a very typical subject and a tricky subject in computer science, and you will get around 9 marks in theory of computation. And I hope every one of you will take advantage of this class and move forward with your preparation. So I just wanted to give a boost up to your preparation by explaining some most important topics. I cannot say that exactly these questions will come in the GATE exam, but I can say this type of models you have to prepare and this type of topics you have to prepare. So you can stress more on these topics so that you will get definitely advantage. And yes, and meanwhile you can keep subscribing the channel if you're not yet subscribed yet, and also keep forwarding to your friends so that your friends can join the session, and do like the session. Yes, I will be starting. Total 15 questions will be there. Each and every question I am expecting answers from you people, and I will explain the solution for each and every question. Okay na? So shall we begin the session? Very nice to see. You can just have a look at this question once. Yes, and don't hesitate to post your questions here. I'm here. I'm very happy to answer all your questions. So please do so. So let L1 is equal to 0, 1, comma 1, 1. Those are true strings in the language L1. And in the language L2, 1, comma 1, 0, 1. These are two another strings. Both are from the same alphabet. Then which of the following string is not present in L1 star L2? So whatever are the strings not present here, you have to identify. So basically, okay, I think I will be just waiting for your response. Then I will explain each and every question. Yes. Yes, Chandan Kumar. I'm expecting answer from every one of you. And guys, don't forget to do like this session and also share with your friends. And I think most of you have subscribed the channel. If not, please do it so. Yeah, thank you. Yeah. Hi, Kausalya. Good evening, Kausalya. Yes. So these are the strings given actually. This is very simple. If you know the regular expressions, you can answer the question easily. Hi Hussein, how are you? Yes, Hiran Thakur. Okay, fine. Okay, now let me explain the solution. I think some of you are giving option A, some of you are giving option B. So let me explain this. Okay. So language L1 is 0, 1, comma 1, 1 and L1 star. So when L1 is 0, 1, comma 1, 1, so the regular expression denoting the language L1 is 0, 1 plus 1, 1. So 0, 1 plus 1, 1 is like a union. So we are having two strings. One is a 0, 1, other is 1, 1. Now is asking about L1 star. So there is a clean closure of L1 followed by L2. So L1 star is 0, 1 plus 1, 1. So any combination of either 0, 1 or 1, 1 can present, followed by L2. So concatenation. So the concatenation with the L2. L2 are the strings 1 or 1, 0, 1. Okay, so that means 0, 1 or 1, 1 whole star, any combination of 0, 1 and 1, 1. And finally, strings end in either 1 or 1, 0, 1. Okay. So in this part we can get epsilon, okay, we can get 0, 1 or 1, 1 and these combinations anytime. You can take continuously 0, 1. In every instance 0, 1 can be taken. In every instance 1, 1 can be taken. 0, 1 followed by 0, 1 can be taken. Or 0, 1 followed by 1, 1 can be taken. 1, 1 followed by 0, 1. In every instance the whole closure is nothing but 0 or more instances. So in each instance either we can take 0, 1 or we can take 1, 1. But it has to end with either 1 or 1, 0, 1. Okay. Actually, if you take option A, so 1, 1, we can bifurcate the symbols. So 1, 1, first instance 1, 1, second instance also 1, 1. Any number of 1, 1s we can take. And ending can be either 1 or 1, 0. So this can be considered as ending. So this is present. So this is not the right answer because which is not present we have to find out. And option B, 2 ones, yeah, 1, 1 is present. And if you take 1, 1, 0, 1 is not there, no? So definitely 1 or 1, 0, 1 should be ending. If you take this 1, 0, 1 as ending, but before 3 ones is not possible from 0, 1 plus 1, 1 whole star. That's the reason. So this is not present actually. So even if 2 instances of 1, 1 is taken, we can't end with 0, 1. Either 1 or 1, 0, 1. So this is a string which is not valid for the given expression for L1 star L2. And for option C, 1, 1, one instance of 1, 1, second instance of 1, 1 and ending with 1, 0, 1. So this is present. And one instance of 1, 1 and one instance of 0, 1, again one instance of 1, 1. So first instance 1, 1 can be taken, second instance 0, 1, third instance 1, 1 from this part only. and ending can be 1 from this part. So either 1 or 101 can come. So this is also present. So option B is the right option here for the question number 1. I think some of you have answered it. Very nice to see this. Please do like the session and share with your friends. Don't forget to share with your friends and subscribe the channel. Yes. Yes, Sachin Gangwar and Chandan Kumar Jaiswal, Thakkar and Kaushalya. Yes, Hussein, all of you are correct. Good. Very nice to see this response. And let me go for the next question. Are you ready? Yes. Please do let me know. Are you ready? Yeah, fine. Now let me move on to the next question. Question number 2. The number of final states present in the minimal state DFA accepting the language generated by the regular expression 000 plus 00000 whole star. So regular expression R is given like this: 000 or 5 zeros. Whole closure indicates 0 or more instances of either 000 or 5 zeros. So 0 or more instances of 000, 5 zeros. Epsilon will come. Okay, single 0 not possible. So 00 not possible. 000 possible, because in this instance either 000 or 5 zeros can be taken each instances. Okay. Yes. I think you people can easily answer. And this is a 2 mark question. So definitely I think every one of you can answer, I think. So please try it. I will give you around 2 minutes of time. So maximum 2 minutes you take for each and every question, because even in the final exam also you may not get more than 2 minutes. Better you practice like that. Okay. Hope you are understanding, and keep liking the session, and do subscribe and do share with your friends in different social media wherever you are present in all the groups, so that your friends also can join and take this an advantage of the most important 15 questions, expected questions of theory of computation. Good. No. Actually, we are talking about number of final states. I did not talk about total states. Definitely, you have to construct a DFA with minimum states. Out of that, how many final states are there in the minimum state DFA? As you know, minimum state DFA is a unique. Yes? Okay. I think you are thinking you are taking too much of time for this. Yeah, this type of questions are very interesting, and you can expect it. This question looks very small, right? Okay, but you have to think a lot. So a lot of tricks are there here, which I have already discussed in some of the other sessions. In Maha Marathon also some questions were discussed, some important questions. You can add these questions also apart from those. Yes, expecting answer from each one of you. Neha has given 4 final states. And what about others? Okay, I'm waiting for your response. Please do like the session, share with your friends, and also subscribe the channel. Don't forget that. Yes. Yes. So most of you are given 4. So let me see. Actually, what is required is what are the number of zeros that are valid, what are the number of zeros that are invalid. If we can list out, so that it would be easy. So for example, if you take epsilon, it is acceptable. Starting state is final. Single 0, because alphabet is containing only single 0 here. There is no other alphabet here. Okay. And because expression is conveying how many alphabet inputs are there. Okay. And single 0 is not possible. 00 is not possible. 000 is possible, one instance of this. 4 zeros is not possible. 5 zeros is possible, because one instance of this we can take. And what about the 6 zeros? 6 zeros are possible. 2 3s are 6. And 7 zeros is not possible. And what about 8 zeros? 8 zeros are possible, because one time I can take 3 zeros, second time I can take 5 zeros. It is possible. And 9, number of zeros 9. 9 zeros, 3 times 3 zeros we can take possible. Number of zeros 10 also possible, because 2 fives. From the 8 onwards every count is possible. Only not possible is single zero, double zero, 4 zeros and 7 zeros. That's all. Remaining all are possible. You can verify. For example, if you have a doubt 13 zeros, how to get 13? 5 plus 5 plus 3. First instance 5, second instance 5, third instance 3 zeros. Okay, now I am constructing the machine here. You can observe carefully. As epsilon should accept, starting state is a final state. And single zero should not accept, non-final. Double zero should not accept, non-final. Okay, if you give a self loop, so that triple zero also will be rejected. That's why different state is considered. Okay, third zero should be accepted. We have to take. For example, if third zero is sent here, 4 is not accepted, 5 is not accepted. That's a problem. So then we have to go for the next 1, 2, 3, 4 zeros. Shall we accept 4 zeros? No, we should not accept. It's a non-final. Okay, and 5 zeros we can accept. Okay, and 6 zeros we can accept. 5 zeros are acceptable, na? 6 zeros are also acceptable. If you give a self loop as 0, 7 zeros also will accept. 7 zeros is not supposed to be accepted. So 6 zeros, 1, 2, 3, 4, 5, 6 zeros acceptable, it's a final state. 7 zeros not acceptable, it's a non-final state. If 7 zeros sent to this, 7 not accepted, 8, 9, again some non-acceptable will be there, because after 8 all are accepted. Okay. So that's why minimum 9 states are required actually, total states. 1, 2, 3, 4, 5, 6, 7. Okay, 7 not accepted, 8 is accepted. So length, number of zeros 8 is accepted. So from 8 everything is accepted, so we can give a self loop. Okay, now the total number of final states are 1, 2, 3, 4, 5 states. I think most of you has given 4, that is wrong. 5 states is the right answer. Exactly, 5 final states. Yes, Thakkar, you have given, very good. And majority of you have given 4 states. Please do check, okay. And this type of things are very important to note down, because just exam is only just very few days, okay. And now this type of mistakes you should not do. That is my suggestion, please. Yeah, 5 final states are required. Yes, Chandan. Any doubt you could ask me, I will tell you. And total number of states minimum, it is a 9 states. With less than 9 states is not possible. The reason I will tell you. If you take less states, again somewhere you have to go back to other states. But after 8 all are accepted, right? So when you go back to other looping, something like non-final states are also there in the sequence, so that some things which are to be accepted may be rejected. DFA might become wrong. Got it now? Okay. Shall I go for the next? Are you ready? Yes or no? Please do let me know. Okay. Please share the class information with your friends, and don't leave this important class, as you know how much practice is required for this subject. Okay. Without practicing nothing can be done, especially this subject. The only mantra for this subject I have been telling many times, is a practice. That's all. Okay. Now coming to the question number 3. Consider the following. I think everybody can answer this. This type of languages you have to be very careful in answering. Which of the following statement is true? Yes. We want a true statement. Next, yes. Good. Good to see your response. I hope all of you are doing great. And don't be idle. Keep on solving the problem, so that yes. 2 languages are given. The option A says L1 is a DCFL but L2 is not a DCFL. Option B says L1 intersection L2 is a not a DCFL. Option C, L1 and L2 are not DCFLs. Option C, L1 intersection L2 is equal to 5. Yes, yeah, I did not receive any response as of now. We need a true statement here. Please respond here. A power n. DCFL is nothing but deterministic context free language. DCFL is nothing but deterministic context free language. Yes. Those who have joined just now, please do like the session and subscribe the channel if not yet done yet, and share this YouTube link with your friends so they can join. Yes, Chandan Kumar, thank you so much. Really, it is interesting question. Good. DCFL means deterministic context free language. So for that, DPDA should be possible. A context free language where deterministic PDA possible. So that type of language is deterministic context free. Actually, every regular language is a DCFL. Okay, but all CFLs are not necessarily be DCFLs. All CFLs are not necessarily be DCFL. CFLs are non-DCF, non-deterministic also can be there. Okay, very simple. L1, A power N, B power M, C power M. I think responses came. Yes. Some of you are given A, some of you are given B. Okay, let me explain. Actually, L1 is a DCFL, L2 also DCFL. L1 is DCFL, L2 is also DCFL. The reason I will tell you. I will tell you how the construction pattern for the push down automata. A's are independent, B's and C's are dependent. So we can skip the A's, we can push B's, and using C's, B's can be popped. So using deterministic approach, we can construct a PDA. And for a language L2, we can push A's. A's and B's are similar, C's are independent. We can push A's into stack using B's, A's can be popped because same number of B's will come, and C's can be skipped, one or more C's. Okay, because no need to remember those things. And for both of them, DPDA possible. In earlier previous sessions, we discussed also how to construct a PDA for languages. Which of the following statement is true? So option A, L1 is a DCFL but L2 is not DCFL. This is wrong. L1 intersection L2 is not a DCFL. This is correct. Because it is intersection of these two languages. Actually, if we see, common strings you have to take, because languages are specifically defined here. For these two languages, what are common? If n is equal to m in both the languages, then only common will be possible. Otherwise, A's are different, here C's are different. So we can say A power n, B power n, C power n, such that n greater than or equal to 1. So this type of strings are common. So this is also infinite language, which is not a CFL because 3 counts. Push down automata is not possible for this. If you push A's into stack, using B's, A's are popped, then exactly NC's we can't skip. That's why option B is the correct option here. Okay, true. It's not a DCFL because when the language is not a CFL, obviously it is not a DCFL. Okay, now L1 and L2 are not DCFL. That is wrong because both are DCFLs. Their intersection, he mentioned it is a phi, empty. No, there is not empty because same A, same B, same C is some infinite strings are there, like strings like A, B, C. AA, BB, CC, triple A, triple B, triple C. These are the common strings in both the languages, right? So this is about the third question, and if you have any doubt, please do ask it. Yes, option D is also wrong. I think some of you have given option B, true. Fine. Now let me move on to the next question. Yes, please do like the session. Question number 4. Consider the language L given by the regular expression a plus b whole star b a plus b over the alphabet a comma b. The smallest number of states needed in a deterministic finite state automata DFA accepting L is. Yes, I think you can answer this question. Question number 4. Quickly finish it. So let me explain this. I think you are working on it. Yeah. Tahir Amin has given 4 states. Good. L is given as, what is the L? A plus b whole star b followed by A or B. So that means second symbol from the right hand side is B. Actually, we are talking about the DFA here, deterministic. But in NFA, it requires only 3 states, because we can give a self loop. We can give a self loop with A and B, and we can give only B here, and A or B can be given to this, and we can go to the final state. That's all. Second symbol from the right hand side is B. First symbol can be either A or B. That is actually, so it can also be written like A plus B whole star BA or BB. Ending can be either BA or BB. Like this also we can write, or we can say second symbol from the right hand side is 1. Actually we may get 4 states. Let me explain this. Okay, say for example BA, we may reach to final state. Just I am trying. So BA and also BB, something like this, and before that we can have any number of A's. So actually second symbol from the right hand side is B, means we can have any number of B's, I think. Okay, BA, because we can end with BA or BB. Ending symbol can be BA or BB. Okay, so that means BA is ending, and we can have BA followed by BB also possible, but BAB cannot be acceptable. BA can be acceptable, BA can be acceptable, BBA also can be acceptable. BBA, for example, if A is given to this, BBA is acceptable. And what about the B to this? Let's suppose if I give self loop, what happens? Triple B also can be acceptable, any number of B's. Again BB, BA also acceptable, and we should not give a self loop B here. Okay, we can give BA, BA. If B is given back to this, it is okay. BA is also acceptable. So second symbol from the right, so it is ending with BA, BB or BA, something like this. Okay, is it clear? Now B is defined, A is defined, B is defined, and for this A should be defined, right? So A, we have to go back to this. BA, AA should not be there. If you give A, second symbol will become A. We can send it to initial state. I hope it is correct. Okay, so we will get 4 states. Roughly, I have given a diagram. You can just recheck it later on. Okay, so but the right answer for this is 4 states. It is impossible to get with 3 states. 3 states is only NFA, it is possible. 4 is the right answer. Now coming to the question number 5. Consider the following regular expression. Which of the following is / or not valid string? So this is a MSQ question. So we need to find out the strings which are not valid here. Maybe 1 or more are possible. Please do it quickly. This is a question number 5. Still we have 10 more questions apart from this. Yes, Vinay Tiwari and all, you are given 3 states. That is not possible. 4 is the right answer for the previous question. Okay. Are you following? Hope you are following me. Yeah, good. Nice to hear this. Yeah, fine. Actually, this one I think it is MSQ. More than one option may be correct here. You have to find out. I think you are working on it. So let me explain once. See the parenthesis very clearly. I am writing it once again. 0, 1 whole plus means 1 or more times 0, 1 can come. And this one or 1, 1, 0. This one. And for this whole, actually one more 1 is there. Whole star is there. Better you expand this so that it is easy. So 1 followed by 0, 1 whole plus 1 followed by 1, 1, 0 and the whole star. This is actual expression. 1 followed by 1 or more times 0, 1 can come. For example, if you take the option A, 1 followed by 0, 1, 1, 1, 1, it is impossible actually. It is not possible. Because either this or this can come 0 or more times. So 111 0, if at all, if a 111 0 is taken, for example, only 0 1 is actually 111 0 is taken from this part, second part. Only 0 1 is not possible. Definitely 1 will be preceded. So this is one of the right option, because not valid. We need to find out a not valid. And option B, you can take 1 followed by 0 1 whole plus means multiple times. 0 1 0 1 we can take multiple times. 2 times I am taking in the place of whole plus, and 111 0 is 1 time. So this is possible actually. It is a valid, not a right answer. And here 1 followed by 0 1 0 1. For example, this is 1 followed by 0 1 0 1 if you take, and single one not possible again. So 111 0 is required. So this is also not valid. And if you take 1 0 1 0 1, 110 not possible. Actually 111 0. This is also not possible. So A comma C comma D. These are the right options for the question number 5. I hope everybody understood this. And B is valid. B can be generated. A, C, D exactly. Yes, Chandan Kumar and Hussein Tucker and others have given right. AC are not valid. AC, D also. 110 will not come because already it is expanded, right? Okay, now let's move on to the question number 6. Let M be the encoding of Turing machine as a string over 0, 1 and L is equal to M such that M is a Turing machine that accepts a string of length 2022. So Turing machine, whether it is accepting or not accepting, we cannot say always, because there is a chance the Turing machine may loop. Sometimes it may halt, sometimes it may loop. If yes or no exactly you cannot say, means accepted or not accepted we can't say. So that means it is undecidable. But as a Turing machine is described, so it is recursively enumerable. Undecidable and recursively enumerable. Option B is the right option. Yes? Is it clear? Why A? I didn't get you. WFD, I didn't get you. Yeah. Epsilon is possible. Amit Sharma. R plus whole star, minimum string is epsilon, and R plus can be, so it can be R star only. R plus whole plus can be R star. Amit Sharma. Okay. Yes, B. Now coming to the next question. Question number 7. Consider the following languages. This type of questions might come. Please observe carefully and prepare this type of questions. L1 is equal to M such that M takes at least 2022 steps on some input. And L2 is M takes at least 2022 steps on all inputs. And L3 is whether M accepts epsilon. Okay. Actually, number of steps, whether it is taken or not, we can say, because a finite number of steps only. Okay. So, number of yes or no answer, if you are able to say it's a recursive. Yes or no answer, you can't say it is not a recursive. That is a criteria actually. Okay. See, we can easily tell whether it is taking number of steps 2022 or not taking, because we can count 2022 steps. It's a finite count. So it is the recursive actually. Yes or no answer can be said for both L1 and L2. But whether accepted or not accepted, to say machine should halt. So we cannot say whether machine will halt or not. But here, even though machine is not halted, but number of steps can be counted as yes or no, answer can be said. That's why L1 and L2 are recursive and L3 is not a recursive. So that option C would be correct. L1 and L2 are recursive. Recursive in the sense yes or no answer can be said. Not recursive means yes or no answer cannot be said. So option C is correct exactly. Now coming to this type of model, you can likely can come because many times from 2014 onwards these questions were asking. That's why in multiple sessions I have included these questions. Okay, now coming to the question number 8. L1 is 1 0 star 1, L2 is 0 star 1 0 star, then the quotient L2 by L1 is dash. Quickly respond to this question number 8. Everybody please. Question number 8. Yeah, meanwhile, please do like the session and share with your friends. Don't forget to subscribe the channel and share the link of this YouTube session with your friends. Please do it so. Yes. I am waiting for your response for the question number 8. So apart from this, we are having 7 more questions. Let's finish those questions also. Right? 1 0 star 1. And even after the class is finished, in the comment box, you keep commenting on the questions with the numbers. So I will try to provide you the solution in detail also sometimes, if possible. And also I will try to answer your doubts in the comment box also, not only in the chat box right now in the live class. Even after the live class is finished also, you will get a service of the solutions as and when you want. Yeah, coming to this one, L1 is 1 0 star 1. So 1 followed by 0 or more times 0 can come followed by 1. So that is a language L1. And language L2 is equal to 0 star 1 0 star. So single one is must. Before and after we can have any number of zeros. So this is the criteria, and L2 by L1 we have to find out. L2 by L1. L2 by L1 is actually, for example, if you take the definition of L1 by L2, L1 by L2 is equal to X, the strings like X will be there. For some Y belongs to L2, XY must belongs to L1. It is very simple. For example, XY is present in L1 and Y is present in L2. Just it is like a division. X will be present in L1 by L2. So we have to find out all possible values of X. That is a challenge here. Okay, for example, if you take any Y, Y can come. So we are finding the Y value in L2 because we are supposed to find out L2 by L1. L2 by L1 means I have to take Y in L1. This is the actual definition I told. Here in specific to this problem, we have to take Y in L1 in such a way that XY must be in L2. So whatever the Y value you have taken in L1, okay, definitely a 2 ones or L1 can be 101 or Y value. So not L1. Y value can be 11 we can take, Y value can be 101 we can take, Y value can be 100, this type of things. But if we concatenate with the X, so this type of strings 2 ones are not present in the L2, right? So there were no such X is present. It is empty. Option B is the right option. No such X is present here. Option B, not 1 0 star. You are finding L1 by L2, not that. I am asking L2 by L1. It's very important to find out. A by B is not same as B by A. Please remember in the division. Okay, we are finding L2 by L1. L1 by L2 is different. L1 by L2 means we can have, even if you take 1 0 star is possible. Okay, now let's move on to this. This is the quotient operation. Now this is option B exactly. Yes, Kanchan, you are right. Anybody else is having any doubt? Please do ask. Yes, fine. Now let's move on to the question number 9. Which of the following decision problems are undecidable? So in the previous sessions, I have already given you some chart of problems. What are decidable, what are undecidable? You can just have a look at on this. And make a note of this point that most of the questions related to regular languages are decidable. So NFAs related to regular languages, right? So intersection of two NFAs is equal to empty. It is a decidable. And if you take any string present in the sigma star, is X belongs to L of G, it is also decidable because we are having a CYK algorithm to check the membership of a string in the grammar. CYK algorithm is to check the membership of a string in the grammar. This is also decidable. And given two CFGs is both are equivalent. So this is undecidable because the equality principle is undecidable. There is no algorithm to compare the pushdown automatas or grammars. That's why it is undecidable. Is a Turing machine is empty, accepted language empty, it is also undecidable. Okay, so only 3 and 4 are undecidable. So option C is the right option for the question number 9. Exactly, Chandan Kumar. So this type of questions actually related to undecidability, this type of questions are important. and don't forget to look out that total table, right? And if you have any doubt, you could ask, and you can also share the class information with your friends. Please do like the session. Yeah. Now let's move on to the next question. Question number 10. Consider that L1 is regular, L2 is a CFL but not regular, L3 is a context sensitive language but not context free, and L4 is recursively enumerable but not recursive. Which of the following statements is / or true? We need a true statement. Guys, please do like the session, don't forget, and also please share the information with your friends. Cross information. Okay, nice to see this. We need a true statement. So this is also, I think, MSQ. One or more may be correct. Let me see. Is / or mentioned means maybe possible to have more options may be correct. So I have covered numerical answer type and also multiple choice questions with negative marking and also MSQ. So out of 15, if you are able to score in this means, I think TOC you will be perfect. I think one question none of you have answered. I think second question. Yeah, please do like this session, guys, and share with your friends. Yes, fine. Okay, now L1 is a regular language, L2 is a CFL but not regular, L3 is a context sensitive language but not CFL, L4 is recursively enumerable but not recursive. So, which of the following is / or true? L2 minus L1 is necessarily CFL. L2 minus L1 is nothing but, we can write this as a L2 intersection L1 complement. So, what is L2? CFL. CFL intersection regular complement is regular. So, intersection of one context free language and one regular language is always a CFL. So, this is a true statement. Intersection of regular and CFL is always a CFL. And L3 minus L2 is necessarily recursive. L3 minus L2 is nothing but L3 intersection L2 complement. What is L3? L3 is here it is a context sensitive language. Okay, so context sensitive language intersection L2 complement. So that is a CFL complement. CFL complement is not necessarily be CFL, but it is a recursive because every context free language is recursive. Every context sensitive also recursive. Recursive languages are closed under complement. So recursive intersection recursive is recursive. Option B is also true. Yes. Some of you have given only one option. That is not correct. And L4 minus L3 is necessarily recursively enumerable. What is L4? L4 is a recursively enumerable but not recursive. Minus L3 means intersection L3 bar. L3 is what? Recursive language. Because every context sensitive language is a recursive language. So recursively enumerable intersection recursive language is always recursively enumerable. So this is also true. And L3 minus L4 is necessarily recursive. So it is written as L3 intersection L4 complement. What is L3? It is a recursive language because every CSL is recursive. Intersection recursively enumerable complement is not a recursive, right? So its intersection also not necessarily be recursive. So this is a false. So only right options here are A, B, C. Yes, Kaushalya, A.B. de Villiers, Chandan Kumar, Hussain. 4 of you are right. Some of you have given only option C. That's not correct. Yeah, guys, please do like this session if you are forgot it, and also please do subscribe the channel and share with your friends before I go to the next question. Yes, and 5 more questions are there. We can quickly finish. If you are already aware of it, I can quickly answer it. Yeah, please. Option 10 B na? Yes, Amit Sharma. So B option L3 minus L2. So what is L3 minus L2? L3 is nothing but context sensitive language, right? So L3 intersection L2 bar. So he mentioned it is a recursive language. Okay, L3 is what? L3 is a context sensitive language. Intersection CFL complement. Actually every CFL is recursive. CFL complement may not be CFL, but it is a recursive. Because every CFL is recursive. Recursive languages are closed under complement, but CFLs are not closed under complement. Yes, Amit Sharma, I hope you understood. So I can consider this as a recursive intersection. This is what I have mentioned. Recursive intersection, recursive is always recursive. So that's why it is taken as true. Yes, now coming to the question number 11. Consider the following language. L is equal to x belongs to x such that x belongs to a comma b whole star. Number of a's in x is divisible by 3 but not divisible by 2. Total number of final states present in the minimal DFA that accepts L is dash. Until and unless you construct the machine, you can't answer this question. You have to construct a minimum state DFA for this so that you can count the number of final states in that. Please do like the session, guys, and please do share with your friends. Don't forget this. And I will be coming up this type of most important questions for 2 more subjects. One is computer networks and digital logic design also I will be taking. So please get ready and prepare and come for my sessions. In advance, I will share you the link of the YouTube. Yes. Amit Sharma, I hope you understood. Clear? Nice to see this. Am I audible? Guys, please do like this session. Before I go to the next question. X belongs to a comma b whole star. Number of a's divisible by 3. Number of b's. So alphabet is containing a comma b. Only we are talking about a's. We are not talking about b's. And let me see how many of you have answered it. Nobody has answered so far. I think you are working on it. Take your time and then. No, I am not talking about the total number of states. Number of final states only. It's quite interesting question. It's not so easy. It is also quite similar to the question number 2 we discussed. If you really like this question, please do like this session once again, every one of you. No. I think most of you are given different answer. Yeah. Okay, fine. Actually, let us talk about how many A's can be accepted. For example, number of A's divisible by 3. So that means epsilon should not accept. B's can be any number. I am talking about only A's. Single A should not accept. 2 A's should not, but not divisible by 2. So should not accept. 3A's can be accepted because 3 is a number. 3A's means not contiguous. Total number of A's present in the string. And because 3 is divided by 2 but not by 2, divided by 3 but not by 2, and 4 should not accept, 5 should not accept anyway, 6 should not accept because it is divided by 3 and also by 2, and 7 should not, anyway it is not accepted, and 8 should not accept. 9 can be accepted, it is divided by 3 but not by 2. 10 should not accept, 11 should not accept, 12 should not accept because it is divided by 2, and 13 should not accept, 14 should not accept, 15 can accept because it is not divided by 2. This type of number of A's. Please do like the session, guys. Okay, now coming to B's, any number. So I am constructing a machine. Please observe carefully. Starting state is not a final state. So epsilon not accepted. Single A not accepted, non-final state. 2A's also not accepted, but 3A's should be accepted. 4A's should not be accepted. 5A's should not be accepted. 6A's also, I am going back to the initial state. 6A's not accepted. 7A's not accepted. 8 not accepted. 9 is okay. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 accepted because it's not divided by 3. Only one final state. 1 is the right answer. I think none of you, total state 6, but I asked about the number of final states. None of you answered it. It's fine. Please do practice this type of questions. It's likely to come. Yes. Are you ready? Shall I go? for the next question. Guys, please do like this session, don't forget, and please keep liking the session and share with your friends always. Okay, now let's move on to the question number 12. It's also quite interesting question. It is also MSQ. More than one option may be correct for this. Which of the following regular expression or expressions is slash r represents the set of all binary strings with the total number of ones 2x plus 1, where x greater than or equal to 1. So number of zeros can be any number, but number of ones are 2x plus 1. So that means we can have 1 1, we can have 3 ones, we can have 5 ones, we can have 7 ones. It's all odd number of ones. It's all odd number of ones. And what about the zeros? We can have any number of zeros. Odd number of ones, and we can have any number of zeros. Only ones are odd, any number of zeros. Yes, please do share with your friends. So shall we? I think you can answer very easily. Yes, Kaushalya. Just yesterday in the previous example I forgot B transitions. Actually, a number of B's can be any number. No, B transitions we can give a self loop. Sorry, only we spoken about A. Yes, AB de Villiers. Very good. Thank you for remembering me. Yeah, B transition self loop. Forget. Otherwise, it's not a DFA. No? Fine. Okay. Now we are supposed to find out the odd number of zeros. So no, it is about number of ones odd, right? Any number of zeros, odd number of ones, exactly. Yeah. So it is also MSQ. More than one option is right option in this. Please try to find out. And just 3 more questions are left over. I hope you have been enjoying the session. And please do like the session if you are really liking it, and also do share with your friends and subscribe the channel without forgetting. Good to see this. No. Yeah. So yes, guys, please do like this session. Yes, Mukesh Singh has given A, B, C, D. Chandan Kumar Jaiswal A and D. AB de Villiers A and D. Kanchan A and D. What about others? So actually there is a lot of potential in the theory of computation subject to ask MSQs and numerical answer questions. Please be very careful in MSQ. Intentionally, why MSQs are introduced in the recent GATE exam from 2021 onwards, to make it more tougher. Without knowing the concept, you can't answer the question, because regular expression is not a unique. We can have multiple regular expressions for one language. Am I right? Yes, Chandan, you are right. And most of you have given, okay. And all are correct actually. All are giving odd number of ones. A, B, C, D. Actually for this DFA is like this. Number of ones are odd. Okay. And zeros can be any number. That means we can give a self loop. So this is a DFA. So 0 star 1 0 star followed by 1 0 star 1 0 star. 0 star 1 0 star followed by this part. It's the even count. And 0 star 1 0 star can be distributed in any form. So all are giving the same. Okay, all options A, B, C, D are correct here. Now let's move on to the question number 13. What is the language generated by the CFG? How are the questions? Are you enjoying the questions? Please do let me know. It's not so easy. So most of the questions are tricky questions. If you are new to this, and it's very difficult to understand. So this I prepared the questions just keeping in view of the GATE examination in the mind. Okay. So every one of you, please try to be in this level of questions, and also try with more number of, yeah. Yes, exactly. MSQ will decide rank. AB de Villiers, yes. Pooja. Are you enjoying this session? Enjoying the questions? You are feeling easy or tough? Do you feel these questions easy or tough? Overall, what do you say? Respond. Yeah, Chandan, thank you. Guys, please do like the session. Yes, Ramdev, Ramdhel. Good evening, Ramdev. Thank you, thank you. Exactly. Sahir Wala, Hussein. Very nice answer. Good. Guys, please do like the session. Don't forget to share with your friends. This theory of computation, as you know, is very essential, and you can easily answer the questions if you know the concepts and practice is there. Guys, please do like it. Okay, fine. Now, actually, the starting symbol S is generating ASB. Actually, in the place of S, ASB taken means S followed by B's will come. But we are having one more option like AAB also. And A's can generate only any number of A's. If you take S to ABB, this is also A followed by B. B can generate only B's. So definitely minimum one difference one will be there between A's and B's. Minimum one difference is there. So that means we can have a string like ABB. So the difference is 1 between A's and B's. And we can also have AAB if A is replaced with small a. So option D is correct. NM greater than 0 definitely. And modulus of n minus m means their difference is minimum 1. Greater than 0 means minimum 1. Greater than 1 means minimum 2. Then AAB, ABB would not have come. So option C, B, A all are wrong. So option D is the right option. Yeah, majority of you have given option D, correct. Now coming to the question number 14. Consider the following grammars G1 and G2. Which of the following relation is true? Yes. This is previous question was not MSQ. This is MCQ. Only one option was correct. AB de Villiers, you are talking about which question? Question number? Minimum 2 years will be there. Which question you are talking about? Not necessarily, no. B option in the previous question. NM greater than 1 and NM greater than 1 means difference 1 means these strings are not possible. According to option B, AAB, ABB strings are not possible. That means it is wrong, na? Kaushalya. Good to see this. Okay, first of all, I will tell you the language accepted by the grammar G1. Language accepted by grammar G1 actually A generates any number of A's followed by same number of B's. B generates C's. So it is something like this. Listen. So this is A power n, B power n, some C power m. A's and B's are same, C's are different. So n greater than or equal to 1 and m also greater than or equal to 1. And the language of the grammar G2, will be like this. A's are independent, B's and C's are same. So it is A power n, B power m, C power m, such that n comma m greater than or equal to 1. These are the two CFLs. L of G1 equal to L of G2, this is wrong. Their intersection is 5, this is also wrong, because their intersection A power n, B power n, C power n. If n is equal to m, common strings are possible. L of G1 is subset of L of G2, wrong. Subset in the sense, proper subset means all the strings of language of G1 must be in language of G2. No, all strings are not present. For example, AA, BB, C is present in L of G1 but not in L of G2. That's why it's wrong. So none of the relation mentioned is correct. So option D is the right option. So L of G1 subset of L of G2 is wrong here. Please remember. So 14th question, option D exactly. Yes, AB de Villiers. Hussein is correct. Chandan, how it is C is Chandan? Not possible. See, proper subset means all the strings of L of G1 must be in L of G2. Yes, none of these is correct exactly. Now let's move on to the last question of this today's session. I hope you have been enjoying the session. Thank you so much for your presence here, and also share with your friends at least the video of this link they can watch. And before I conclude the session, every one of you, I am expecting right answer from this question. The number of states present in the minimum state DFA, total states, I am not talking about final states here. The number of states present in the minimum state DFA to accept all the prefixes of the following sequence. The sequence will go like this: alternate 0, 1, 0, 1, 0, 1 and so on. Please make it fast. Prefix is nothing but, as you know, all the leading symbols. Set of all leading symbols is nothing but prefix. I think you can answer this easily. Yes, Sahil Khan. Pattern is different, and this, see, subset or superset to decide is not a pattern, Sahil. We are deciding the strings actually. Alphabet is same for both the languages. I am talking about previous questions. The Sahil has asked one question. Sahil Khan. Pattern is not same. Alphabet is same. Yes. Okay, let me explain this. Actually, we are having prefixes in the sense epsilon is a prefix, 0 is a prefix, 0, 1 is a prefix, 0, 1, 0 is a prefix, 0, 1, 0, 1 is a prefix, 0, 1, 0, 1, 0. So these are all the prefixes. All these prefixes must be acceptable. Okay, so epsilon to accept, starting is final. Single 0, I have to go. Double 0 should not accept again. Single 0 only, I have to go to another final state. 0, 1 can accept. Okay, 0, 1, 0 can accept, 0, 1, 0, 1 can accept. So we require to have a dead state. So from here 1 is missing, we can send 1 to this, and from here 0 is missing, we can send 0 to this, and dead state 0 or 1 is a dead state. So total we get 3 states. Option A is the right option. So regular expression is for this final state, okay, A 0, 1 whole star, or if this is the final state, 0 of 1, 0 whole star. These two things will come, either 0, 1 whole star or 0 of 1, 0 whole star. So option A is the right option. Is it clear? Yes, very good. 3 states, including the dead state. You have to count the dead state in the number of states. Guys, please do like the session if you really liked it, and also please make a copy to your friends. You can share the class information, at least the video they can watch, and you can continue posting your doubts in the comment box. I will be handling and I will answer those questions. Thank you so much. Thank you one and all. I hope you people have enjoyed the session, and if you have any doubts still, you could ask me. Otherwise, I will conclude the session. Yes, we have to count the dead state if there is a dead state, but every DFA may not have a dead state. But if the dead state is there, it has to be counted in the number of states. Otherwise, if you don't define a dead state here, it's not a DFA, right? It will become NFA. Yes, hope you understood. And once again, go through all the questions. I suggest you, because and have a discussion among yourselves if you have any discussion forum, and you can just try to practice this type of questions more. Yes, thank you so much. Thank you one and all. I hope you people have enjoyed the session. Thank you one and all. Have a good night. See you all. Bye bye. And I will come up with 2 more subjects, computer networks and digital logic design, and we'll discuss there. Thank you so much. Have a good night. See you all.